Okay, so now we go on and we talk to bias in this fourth video of the day. I had the problem again with on the last video. I do apologize for that. I know you can still see it anyway, so I'm not worried about it. But it looks a whole lot better as I'm looking at it on the screen, how it normally looks to you. So hopefully this one comes up. I actually exited the program and started it again to make it look that way. Next, bias. Bias, look, you know what bias is in our language. It's like prejudice against a particular race or gender or ethnicity or anything like that. Bias is a really terrible thing. But the concept of bias is that there's a built-in wrong about it. It's not fair. And bias is the tendency of a statistic to over or underestimate a particular parameter, a conclusion based on the whole population. So a really good example of that was like if you're doing a survey on music, there would be a bias built in if you only surveyed people who like lived in an urban area, and you were like, well, do you like country or do you like rap? But then you go down to down south and you go into the rural areas and you ask, well, they're not going to like rap, they're going to like country music. So it's a big difference between the two. Types of statistical studies. First type is an observational study. An observational study is a study in which the researcher simply observes the subject and doesn't interfere. He just sits back and he watches. I guess that would kind of be like Darwin with the finches on Galapagos. That is, the researcher has no control over any treatments the subjects may be given or which groups the subjects may be separated into, etc. He is basically as impartial as it possibly gets. Lack of bias. In an experiment, well, that's a controlled study in which the researcher attempts to understand cause and effect relationships. The study is controlled in the sense that the researcher controls how subjects are assigned to groups and which treatments each group receives. So those are for observational things. Now we can also talk about experimental studies. And within these experimental studies, there's a treatment group and there is a control group. In the design of experiments, treatments are applied to experimental units in a treatment group. In comparative experiments, members of a control group receive a standard treatment, a placebo, or no treatment at all. So for instance, maybe they're testing a drug that's all about losing weight. And there are two different groups of people. And one group gets the actual drug, and the other group gets one that looks just like it, tastes like it, does everything like it. They take it at the same exact time, but it's actually, say, nothing but a little sugar pill. And it doesn't do anything to them at all, or a sugar substitute pill, so that there's no effect from this. The one with no effect is called a placebo, okay? And the treatment group obviously gets the real treatment. It is important for the treatment and the control groups to be selected randomly and to be alike in all respects except for the treatment. If they're not picked randomly and they're not alike, then whatever the thing is that one group is all like and the other group is not could be the difference. That's why it has to be random. Okay? The placebo effect and blinding. Now, what's really important is that when you do these studies, you don't want to know who's who in it, because it can affect, if you are the person recording the results of this, it can affect what's going on. Like let's say we're talking about fishing, okay? And or let's say you're going out for a sport team, okay? And the coach knows, like everybody knows this from Little League, right? Like the coach's kid goes out for the team. Well, coach's kid usually gets favored. Maybe it's the opposite. Every once in a while, the coach is a little harder on his kid. So the fact that he knew his kid affects his judgment with how that goes on, and it could affect his playing time. Rare is the coach that keeps that fair. So that's what goes on with the placebo effect. In an experiment, subjects respond differently after they receive a treatment, even if the treatment is neutral. Okay? A neutral treatment that has no real effect on the dependent person is called a placebo. That's what I meant before about the little pill that has no medicine in it whatsoever. Okay? and the subject's positive response to a placebo is called the placebo effect. One of the things they found is this: if the person believes that they're getting the same pill that the other person gets, sometimes they will believe they're getting cured to the same extent that the person is. And that's what we call the placebo effect, because they think the pill is going to do it for them. You take a pill to get your headache away, and then all of a sudden your headache goes away, but the pill was a fake pill. It wasn't a real pill. And you go, oh man, that was really good. Well, that's because it's what they call a psychosomatic event. You thought that it was a real pill, but it wasn't a real pill. So you kind of did it on your own. The pill didn't do it. Okay. Now, what are single blind and double blind? Well, being blind means that you don't know if you're the regular one or if you're the treatment group or the placebo group. In medical trials, the term blinding or double blind usually refers to the practice of keeping patients in the dark so that they don't know as to whether or not they are receiving the placebo or not. Blinding or double blinding is when a patient doesn't know what treatment they are receiving. It didn't mention it here, but I was always taught in double blind trials, not even it does say it near the end, not even the doctors or the clinical team know who's getting the placebo and who's getting the real pill. Okay, so double blind means the patient doesn't know and those running the study don't know, and single blind would mean that the patients don't know. Now, observational studies, okay? Obviously, instead of it being controlled, we're just going to observe. A case control study is, and the participants and so on. A case control study is a retrospective study. It looks back in time to find the relative risk between a specific exposure and an outcome. So for example, like when I was a kid growing up, nobody talked about secondhand smoke, nobody. And my parents, they used to put us in the car and they would roll the windows up, and they were both heavy smokers and they would smoke like crazy. We would be gagging, my sisters and I, in the back, hating every minute of it. And we'd like beg them to roll up the window, and they didn't do it. Now, back then, nobody knew about secondhand smoke, so they didn't think they were harming us. Nowadays, people in their own home go outside the front door to smoke. They don't smoke in the house, or at least very rarely do they do that, okay? Another example would be Agent Orange. Our veterans in the Vietnam War, in that war, we used this defoliant by the name of Agent Orange, and then they started to realize, looking back after the war was over, hey, how many of these soldiers started getting cancers and medical problems from using Agent Orange? Another one could be, years ago, there were problems where the osprey started to disappear and bald eagles started to disappear. And what they realized is that farmers were using a chemical called DDT, and the DDT was weakening the eggs of birds that fed on the fish. The DDT would run off into the water, the fish would ingest the DDT, and then all of a sudden the birds are feeding on the fish, and now their eggs are so soft that as they sit on the eggs, they're breaking. So those bird populations went down, and then we banned DDT. So anything that looks back after the fact, all right, defines a relative risk between a specific exposure like secondhand smoke or DDT or Agent Orange and the particular outcome like broken eggs or cancer. A control group of people who do not have the disease and who do not experience the event is used for comparisons purposes. An observational study observes individuals and measures variables of interest, but doesn't attempt to influence the responses in any way, shape, or form. Completely impartial. Data is collected. Nothing is influenced by the researcher, theoretically. An experiment deliberately imposes some treatments on individuals to measure their responses. Now, this is pure statistical science, and that's the way it should be. Unfortunately, you do have to be aware. For instance, going back to politics again, if you watch the network Fox News, you tend to be very conservative in your points of view. If you watch CNN or MSNBC, you tend to be very liberal in your points of view. So if Fox News puts up a poll, you should know that, it's got a different predisposition than a CNN poll or an MSNBC poll. And if they look back on the facts even, they're going to try to have something that comes up their way. So you've got to be a little careful about bias built into any of these conclusions. Okay? An experiment deliberately imposes some treatment on individuals to measure their responses. For example, a National Cancer Institute study of 716 melanoma patients and 1,014 cancer-free patients, so you got to have both kinds there so you can compare, matched by age, sex, and race, which means that, like, for example, cancer tends to happen to you when you're older. So if one of these groups is only 15-year-olds and the other group is 75-year-olds, of course the cancer group is going to get it. The older group is going to get more cancers. So they made sure that the groups matched by age, male, female. For example, type of cancer is called prostate cancer. Only men get it. Women don't have a prostate. So you have to be careful about that. And race, because there are certain illnesses that are far more prevalent in one race than the other. So they found that those having a single large mole had twice the risk of melanoma than someone not having a large mole. If you have 12 or more moles associated with it, 12 times greater risk of melanoma. Is this study observational or is it an experiment? If it is an experiment, describe the treatment and control groups to discuss whether single or double blinding is needed. If it is observational, state whether the case is case controlled, whether it is case controlled, or if so, which are the cases and which are the controls. So, it's definitely observational. It is case controlled. The cases are melanoma and cancer-free. The control is the presence of moles and how many, and that's going to relate to the percentage of cancer that you get, or the percent chance that you're going to get cancer. Example, a hypothetical study of 45 swimmers found that those who were placed on a weight training program, in addition to daily swimming workouts, improved their times by 3.5%. Is this study an observational study or an experiment? If it is an experiment, describe the treatment and control groups and discuss whether single or double blinding is needed. If it is observational, state whether it is case controlled, and if so, which are the cases and which are the controls. Go ahead. Okay, so this is clearly experimental. There's no blinding in this group whatsoever because you can tell who's doing the weightlifting and who's not. It's all about the weight training and does it affect your performance. The control groups are those who did weight train and those who did not. Okay, our last card for today's lessons. In the following scenario, what type of statistical study would most likely lead to an answer and why? Do drivers of the same model car get better mileage with high ethanol fuel? Now, by the way, I can personally tell you that if you can drive without ethanol, it's a good thing and you don't want to do it. I don't know the difference in miles fuel's done, but I do know that ethanol damages your engine a lot more than no ethanol does. So, all right, this is observational. The researcher doesn't need to influence or control anything. All they do is look back. They get the answers afterwards. They say, okay, what kind of car do you drive? What's your mileage? So you're looking back on it. It's retrospective, which makes it observational. They're observing the mileage that each of these cars get and whether or not they used ethanol gases. All right, that is the end of lesson 17. Next time will be lesson 18.